Welcome to IT.Solution, your total network, system, firewall, and security partner.
All right, let's dive right into this explainer and crack open exactly how networks achieve seamless redundancy at the default gateway layer. If you're working your way through the switching, routing, and wireless essentials curriculum, specifically Module 9, then you already know that keeping a network up and running is basically the holy grail for any network engineer. So today, we're going to look at the clever under-the-hood mechanisms that keep traffic flowing even when your core hardware literally fails. To get you totally comfortable with these CCNA level concepts, we're going to hit 5 quick stages. 1. The default gateway problem. 2. The virtual router illusion. 3. Router failover in action. 4. The FHRP family. And finally, 5. A spotlight on HSRP. Okay, starting with Section 1, the default gateway problem. Let's look at how a totally normal network setup can actually create a massive vulnerability. To set the stage here, I want you to just picture your current network. Your end devices, like the very PC you're probably watching this on, they're typically configured with just a single default gateway IPv4 address. Now ask yourself, what happens to your LAN hosts if that specific router interface suddenly dies? What if someone unplugs the wrong cable or a power supply just completely fries? Well, this is the exact pain point we're talking about. If a PC is configured to use Router 1 as its one and only default gateway and Router 1 fails, that PC is completely cut off. It can't hit the local server, it can't reach the internet, nothing. And you know what makes this so incredibly frustrating? Another perfectly good router, like a Router 2, might exist right there on the exact same network, but because the PC doesn't know to send its traffic over to Router 2, all that expensive redundancy is completely wasted. It is your classic single point of failure. Right, let's jump to Section 2, the virtual router illusion. Because what's really cool is how network engineers solve this exact problem using a bit of technical sleight of hand. The absolute hero of our story here is the First Hop Redundancy Protocol, or FHRP for short. Now, FHRP isn't just a single protocol. It's a whole category of mechanisms designed to fix that single point of failure. And how do they do it? By letting multiple physical routers team up to create the illusion of just one single, highly reliable router for your local hosts. So the crucial thing to grasp is how this illusion is actually built. You have a physical active router. Let's say it's configured with a priority of 150. Then on the same network, you have a standby router, maybe with a priority of 100. Together, they perfectly share a single virtual router that sits logically right between them. This virtual router gets its own virtual IPv4 address and its own virtual MAC address. So those PCs on the network, they aren't configured to talk to the active router, and they aren't configured to talk to the standby. They're configured to talk exclusively to the virtual router. Honestly, it's exactly like a Broadway play. The active router is your lead actor, and the standby router is the understudy. The lead actor is out on stage doing all the heavy lifting, routing the packets. But if that lead gets sick, if the active router drops, the understudy steps seamlessly onto the stage. And the audience, the PCs on your LAN, they have absolutely no idea anything changed. Their ARP tables stay exactly the same. Their default gateway settings remain completely untouched. It's 100% transparent failover. Moving right along to Section 3, router failover in action. Let's see what this magic trick actually looks like when disaster strikes. The failover process is honestly a thing of beauty because it happens automatically, usually in 3 very quick steps. First, these routers are constantly talking to each other. If the active router fails, the standby router stops receiving its periodic hello messages. Second, the sudden silence acts as a trigger, making the standby router instantly assume the active forwarding role. It immediately takes ownership of that virtual IP and virtual MAC. And third, because those IP and MAC addresses haven't changed at all from the host perspective, there's practically zero disruption. Just picture the exact moment of failover. The primary link completely goes down, but the data traffic, it just instantly pivots. The standby router becomes the brand new forwarding router. It picks up that virtual IP address, and the PCs just keep humming along, happily browsing the web or pulling files from servers as if nothing ever happened.
Okay, Section 4, the FHRP family. Now that we get the concept, let's explore the actual protocols you can use to pull this off. You'll definitely want to lock this into your memory, especially for your CCNA exam. These are your 3 main FHRP options. First up is HSRP, which is Cisco proprietary. It uses an active/standby approach, meaning one works, one waits, and it balances the load on a per subnet basis. Next is VRRP, which is an open standard, so it's great for mixed vendor environments, and it also uses that active/standby model. Finally, we have GLBP, another Cisco protocol, but notice the huge difference here. GLBP uses an active-active redundancy approach, which actually allows for load balancing across multiple routers on a per-host basis.
It's also super important to know how these protocols have evolved to handle modern networks. While HSRP is everywhere, you should know VRRP comes in an IPv4-only version 2, which historically used master/backup terminology. If you're running IPv6, you'd step up to VRRP version 3. GLBP also has an IPv6 flavor that protects traffic while actively sharing the load. Oh, and just for some historical context, you might occasionally hear about IRDP. That's a legacy solution for IPv4 host router discovery, but you really won't see it much on modern networks.
Finally, let's wrap up with Section 5, a spotlight on HSRP. We're going to double-click on Cisco's Hot Standby Router Protocol.
As we touched on, HSRP is Cisco's go-to proprietary protocol for transparent failover. The absolute key takeaway with HSRP is its strict active/passive model. The active device handles literally all the routing for the subnet. The standby device, it just sits there, listening for those hello messages. Who gets to be active is determined by configured standby priority, highest number wins, along with a feature called preemption. And if you're running IPv6, HSRP seamlessly generates a virtual link local address and uses periodic router advertisements to keep the whole network informed.
But here is the one big catch with HSRP. Because of its active/standby design, it does not share the workload across both routers simultaneously for a single subnet. Meaning, for any given VLAN, one router is sweating through every single packet. Meanwhile, the other router, which, let's be real, you probably paid thousands of dollars for, is just chilling on the rack doing absolutely nothing, waiting for a disaster. If you want both routers to earn their keep at the same time, you either have to get creative with multiple VLANs and alternating priorities, or switch to something like GLBP.
Understanding how to keep a network breathing during a massive hardware failure is, for sure, one of the most vital skills you can master in your CCNA journey. So, as you head into the lab for Module 9, take a hard look at your own network's default gateway. If someone unplugs the core router right now, does your network survive the afternoon, or does everything just completely grind to a halt? It might be time to deploy an understudy. Thanks so much for joining this explainer, and we'll see you in the next one.
Thank you for watching. See you in the next episode.